running this, or hosting, I suppose, not running it. Thank you, all the rest of you for putting it together. I get to pitch all of you, which is my favorite. So I work at MotherDuck. We are a cloud data warehouse built on top of DuckDB. Out of this room, who of you has used DuckDB before? Raise your hand. Okay, we've got like 10 people. Okay, great. That means I get to talk to you about what it is. So it is an in-process SQL OLAP query engine. Okay, what that means is it kind of operates like pandas or polars, actually very similar to those two things. And instead of using kind of data frame invocations, it uses SQL. It's super, super fast. It's vectorized. It can run in a bunch of different places. There's pretty much builds for everything you could possibly imagine, every platform. It runs on a bunch of weird stuff. It has really nice SQL support. It has a bunch of plugins, including things like geospatial. It has a really nice ecosystem there. Lots of things that can fit in. And of course, it can read basically anything that is the flat file format. This includes your favorite data lake formats and so on, which I will talk more about later. But what that really means is you don't need to move your data around just to use DuckDB. You just use it where it's at. And that means you can run your compute really, really close to your data. You don't need to put it in another database first. You don't need to move it to Databricks. You don't need to move it to Snowflake. You can just run it there. So what we're doing with MotherDuck is we're taking that in-process OLAP engine and we're extending it to the cloud. It's serverless, so you only pay for what you need, and you get as many nodes as you want. So it is a single node system, right? Your biggest queries, if you have like more than like, I don't know, 50 terabytes or something, you probably can't run that on a single node. But for everything else, you can run on our nodes, and you can get a bunch more of them too. So where we actually see a lot of customers coming into MotherDuck is when they have like a customer-facing analytics problem, where they have a bunch of different customers, and they all basically have the same data model, and they want to serve that data to their customers. We can actually partition that by database through serverless billing, so that you can get basically every customer is isolated from each other. There's no crosstalk. It's super, super fast. It's super cheap, and it's really an excellent interactive experience. And the last thing we do that's really cool is we are distributed between your laptop and the cloud. And so what that means is when you're interacting with MotherDuck, you can run queries locally and in the cloud, depending on where your data is. That also means your laptop is also a proxy for, I don't know, a really big EC2 instance, or anything else where you want to run DuckDB, right? So you can just run DuckDB there, run it on data locally, and then join it on data that's in the cloud. And that ergonomics is very, very helpful, especially for like, I don't know if you're dealing with like edge compute, maybe IoT, where you want to run some of the compute on the local device and then send the rest up to the cloud. One thing that I really love about this too is we have a WASM engine. What this means is you can run the full database in the browser. Because you're running the database in the browser, you can offload a bunch of your compute to your users, which sounds bad, but it's very fun. So obviously, if you're building a data warehouse, you have to have integrations. We have a bunch, including some very fun things. You see Python, or Python and Jupyter and Colab, etc. For those of you that are kind of in the more on the scientific computing type of stuff. I'm actually going to jump into something in a little bit that is in that vein. I just want to make sure I'm good on time. So let's talk about data lakes. So for those of you that are kind of more in the hardcore data space, you've probably heard a lot about them, right? You've probably used Databricks, right? You've probably used Delta tables or Iceberg. Iceberg is super hot right now. This is what the Iceberg kind of stack looks like. You have a catalog, which is just a database. You have a metadata layer, and then you have your data down here. And this is kind of an interesting decomposition of all the different pieces that you would put maybe in like a traditional database. And it introduces some problems. I like to sometimes tweet about things, and someone said, "What does Iceberg come from?" This is how long it takes to write a single row. A long time, actually. If you're, generally the Iceberg experience, for those of you that have interacted with it, you have kind of the choice of using Iceberg, which is okay, it's a little immature, or you can use Spark, which is kind of the reference implementation and is Spark. So you get to enjoy that piece of it. So the folks at DuckDB have said, what if we rethink how this works? what if we just reintroduce the database, because we have a really fast local database, what if we just reintroduce that and put all this stuff into the database, okay? They just actually announced this yesterday, so this is brand new, cutting edge stuff that we get to see in a little bit here. And so what that does is, because all of our metadata is local to a database, querying is actually really fast, and it's really easy for us to do multi-engine writes, which are really, really hard to do today with the traditional catalog solutions like Unity and Polaris and so on. So we're kind of bringing all of that stuff back together. And for those of you that kind of know a little bit of how Snowflake's architecture works behind the scenes, this is basically the Snowflake Iceberg implementation. It works more or less this way. All of this data is in, can't remember database, Foundation DB maybe, and then Iceberg down here. So there's DuckLake. This is what came out yesterday. It was announced by our friends in Amsterdam, and it takes all these pieces and that complex architecture that looks like this, right? Just now looks like what we have here on the right. It's much simpler, right? It's like you kind of see what you get, you understand how it works, you understand where your bottlenecks are. It's easy to implement. It's fast. So, and critically, no Spark required. So no Java, which is great, makes me very happy. Hopefully makes you happy too. So let's jump into a demo that I have, showing you how this works just kind of in a basic level. Let's see if I have my server running. I do, if I can find it. There we go. So this is Marimo, which is a notebook, Python notebook. I don't know if any of you have used it. They're kind of have come on recently. I kind of enjoy using it a little bit more than I like using Jupyter. And so it has a really nice DuckDB integration, which I'm going to kind of show you here. So we're going to walk through these. I'll just kind of talk through the code here. In this part, if you have questions, feel free to just be like, what does that mean? I'm obviously familiar with this stuff. I work with it all the time, so I might be skipping over some details. So the first thing we're going to do is import the Marimo kind of base package, and then we install DuckLake. So this is actually a SQL cell. I'm just going to toggle it so you can see what the Python looks like. So the Python looks like this. So Marimo has like a SQL function that lets me just execute SQL inside it, right? So I run that, and then it attaches my database, which I can now see here on the left-hand side. Here is my DuckLake kind of database, and here's all the metadata. So this is the database. It's called my DuckLake, that is holding kind of the actual data, or the representation of the data. It's really just kind of views on top of Parquet. And then here's all the metadata in this metadata database. Okay. So we can attach another data set. For those of you that don't know, I'm a really big NBA fan. I work on a side project called MBS in a Box, which is like an NBA simulator. So I have a bunch of NBA data lying around, including this set of stats, which I am now attaching. So what attaching does is it just makes that available as and addressable with that name in DuckDB. So now that we have access to that other database, we can do some fun stuff with it. So the first thing we're going to do is create a table in DuckLake. So it just looks like this, right? Just normal SQL. And again, if you want to see the Python, it looks like this, right? We have the Marimo SQL function that we're using, and we can just run it, right? Now we have an empty table with the right schema, and we can actually kind of see what it looks like. I'll just show you. So here's my table. So it has all this information. You can see it's kind of like key value pairs here, stat name and value in the table. So the next thing I'm going to do.
I'm assuming everything in that sidebar is coming from your extension.
Yes, from this database.
Yeah.
Yeah. This is all the stuff that I've attached. So we have a memory database by default. When you attach DuckDB to Marimo, you get an in-memory database, which I'm actually not using, and then these other ones are physically materialized. Okay, so the next thing I'm going to do, which is kind of interesting, is I'm going to show you just this little Python snippet. So I'm going to get from my database, right? I'm going to get all of my game IDs. Then I'm going to take that list and I'm going to bring it into Python, and I'm going to iterate through each of those. And so I'm going to do it like this, right? And then I'm going to sleep. And why I'm going to do this is mostly just to demo kind of some DuckLake time travel stuff, right? Sleep is totally unnecessary, you don't need to do it this way, but pretend these are transactions and you get the gist of it. So this takes like 2 minutes. Here you can see how long it takes. 90% of that is sleeping. So we have about 1,300 games in here, so we've got about 1,300 inserts. It's like 2 minutes and 20 seconds or something, and the rest of it is just processing time. So we have that. So now, once this runs, I now have all the data available. Let me just add a cell so we can just. How do I want to do this? I'm not going to do that actually. So the next thing I want to do is, because I have kind of a key value pair set of data now in my data lake, right? I have these stat name and stat value columns. I can't really use these kind of like by themselves. I have to do a little bit of processing on it to make it usable. And I don't remember what the names are of my columns. Common problem, or actually what those are. So again, I can write SQL. Again, it looks like this in Python. And I can use this handy little search here to be like, what about rebounds? What about rebounds? Okay, so here's all the different rebound stats that I have. I'm going to use this one right here. And then we're going to just take a look at our snapshots. So again, this is just looking at our DuckLake snapshots table and saying, hey, what's in there? What's in this object that we called my DuckLake? Are there snapshots in there? I'm just checking to make sure I did this right. And then the last thing I have here is I'm going to introduce a Python UI element here in my notebook that's just slider, right? So I can just slide this around, okay? Now why this is cool is I can tie this version to my SQL query down here, okay? So you can see that I just passed this Python element straight into my SQL, right? And so by doing that, now what I can do is I have my query here that says, all right, I want to get my player, I know you, for those of you that like Python, you're probably like, this is a lot of words for like a very simple data frame operation, and you're right. Just to be clear. We have kind of a basic query here, getting the top 10 players on rebounds here, and we're sorting by high to low, right? And because we have this filter on version, and we have 1,300 versions because we had 1,300 games in our data set, we can actually start pulling this slider around, and it'll just query our data on the fly, right? So what I'm actually doing with this is I'm time traveling every element here that I'm pulling this version label here, right? So if we want to see the full season data, we just pull over to the right. Okay, we can see Demontis Sabonis, Winter Gonzaga, shout out Gonzaga, was the season leader in average rebounds per game, right? So this is the type of stuff that is available today with DuckLake, right? This is all running locally, kind of building, running my database locally, very, very fast, right? Pretty much every interaction is re-querying my data set, right? Which is very cool. And the last thing I want to show you is, because I enjoy doing some charts that look kind of nice, although this one doesn't look that nice because I just built it, but we can actually pass this SQL data set as a data frame. So I actually defined it right here as RDF. And so now I can just simply pass this data frame that's a SQL query into a chart, right? So again, if I just move this around, we'll see different results in our chart. So yeah, that is the kind of mother duck Python SQL integration that we have now with DuckLake. Actually, this is all DuckDB right now. In the future, we will have the ability to add the DuckLake catalog elements into mother duck and run it there too. Hopefully in the next few weeks. We'll see. Yeah.